All right, I got some customers.
Hi.
Ashley. What's up, Josh?
Hey, Professor.
How's it going?
Good. Can't complain.
Good. So did you get the problem figured out?
I did. I did do that one, and a couple of the other ones as well. Let me see which ones. I was on. Yep, getting ready to for number four.
Okay, that's the tornado.
Yep, four, and yeah, the reading. Then
Okay.
I wanted to listen in. Yeah, see if you're having another session like the other day.
Yeah, I thought we'd have bonus to see if people have questions, but Ashley, you have a question or are you hanging out too?
So I probably I have a I have a few right now. What I'm doing is I'm finalizing 3C,
Yeah.
and I'm I'm hoping I did the other ones right. Um, I went back and just listened to the whole recording and then walked through. I think where I'm getting a little tripped up is I know it's the same process to start, but you start them in different sessions. Actually, so what you have pulled up right here, that's exactly what I'm on. So I did my diagram
Yeah.
and I have the productive and not productive. And then the only thing is just because I'm trying to use a model, like I rewrote the same kind just so that I could do it myself, right?
Yeah.
And I have drill, no drill in between the success and fail. So I don't know if this is going to make sense, but let me tell you why I'm getting tripped up. So you have the probabilities on the outside. I know how we got the 18, 14, 12. I know all of that, right? And now you're dividing essentially 18 into 32 to get the percentage on successful. I think I'm getting confused and maybe I'm answering my question right now. I guess the 18, 14, 12 is recreating the probabilities that use that like in the blockbuster disaster, it's the same probability as like the 20, the -5, the -1. Am I making sense?
Yeah, you want me to share my screen to
Yeah, I see your screen.
No,
Oh, wait,
I'm
you know
not
what?
sharing.
Oh, I'm sorry. You know what? I was still looking at my screen of the recorded number. Okay, yes. Let me find you.
Okay. Yeah, so I made a spreadsheet
Oh,
that implements them all, and then I made a video on it beyond the office hours. But um, so I think you were talking about these probabilities. So we have to calculate, given the data, what's our new belief about the likely success of the well. So the way we do that is by flipping this tree, because the information was given this way, 30% chance the well's a success. But we want to know, given the seismic says productive, what's the chance of success? And so that's a different number. That's not going to be 30% anymore. And if the seismic says this is going to be unproductive, then the probability is going to go down. So the first step for C is we've got to calculate these conditional probabilities. And so we do that by building this tree. 30% chance the well will be a success. If it really is going to be successful, then 60% chance seismic will say productive. If it really is going to be dry, then there's an 80% chance seismic will say unproductive. So with the numbers in blue, everything else is determined. Given the blue numbers, everything else is just a calculation. All right, that's 0.3 times 0.6, 0.3 times 0.4. Those add up to 0.3. They better because we've just divided them 60-40. This would be 0.14 and then 0.56. And those add up to 0.7 because we've just divided them. So then we have to put the tree in the other order. So then we start with the joint probabilities. So the middle two flip. And then I can calculate everything else. This is the sum of these two numbers, just like this is the sum of these two numbers. This is the sum of these two. 0.3 times x equals 0.18. X would have to be 0.18 divided by this 0.56. This times this equals that. So let me stop there. These are the numbers that we need. We need these numbers to put into the tree.
Yeah, so I guess what I was saying is that I saw the Excel sheet. I went in there, which is great. I was trying to like recreate it on my own though,
Mm-hmm.
so that I could kind of like make sure that I could walk through it. And then so what I'm saying is in the blockbuster, we had the probabilities given to us,
Yeah,
right? Which is your point. It's the 20, the -5, the -1, that kind of thing, right?
I
And
gave you
this,
this tree. Yeah.
yes, and I'm even just thinking of like your example, like I'm envisioning the decision tree that you showed us, where you drew it out. We had the probabilities on the side. So
Yeah.
if I say, exactly, so if I say I take that same thing and I recreate the drill, the drilling A and B didn't start out with that. We didn't start out with having to calculate the probabilities. We started out with like the numbers, like 100
Mm-hmm.
minus the. So I think that threw me for a loop as to, I can do the problem when I walk through it. Is there something I'm reading that makes me realize that I'm not starting out that way? Does that make sense? Is there something that I'm seeing that makes me realize that I have to flip it and go back and figure that out that way?
So we always have to get to this structure right here, where you get the test result, then you decide what to do, and then you see what really happens. All the problems have to have this structure. So we have to get to those probabilities. For Ursa, I started exactly like the drilling example, but I did the calculations before we got into the room. So I could just give you these probabilities. So, I mean, the way to think about it be, this is the tree we need, and you need to do whatever you need to do to get these probabilities. So if you weren't given the probability of a blockbuster given hit, you're going to have to calculate it. If you weren't given the probability of the wells a success given productive report, you're going to have to calculate it. You're valuing a test. So if you haven't been given what's your new beliefs after seeing the test, you're going to have to calculate those probabilities. Does that help?
Yes.
So if I would have given this would be like identical to Ursa. Just, hey, here's the probabilities. Roll it back. What's different here is you got to calculate these conditional probabilities. And so that's putting together what we did earlier, flipping the tree to calculate the probabilities, the conditional probabilities that we need. But you got to get, in all cases, we need these numbers. But we gave them to you for Ursa. Or you could, for Ursa, even if I didn't give them to you, you could have calculated them from this table. Like if they say hit, the chance of a blockbuster is 20 out of 25. So, you should be able, even if I didn't give you Ursa, you can get them from the table. Because given the test result, 20 out of 25 times it's a blockbuster if they say hit, and if dud, then only 10 out of 25 times is it a blockbuster. They're getting closer. We can let you noodle that, Ashley, a little bit. Let's see if somebody else wants to ask a question. Who else has got a question? Frank's back. Frank, did we get all your questions answered?
Yeah, I mean, I calculated it going back to your example, and I convinced myself that I understood how to do it, so I think I'm okay. I didn't get a chance to watch your asynchronous video, so I was planning on doing that at some point this weekend. But I mean, the logic makes sense that you have to, I think the key was you had to break it up into two calculations. And so once I understood that logic, then I was able to kind of do the route tree myself, and then just kind of compare it to what you have on the screen now to show that I came to similar results. The only difference is that my answer for the value of imperfect information was 0.2 because I calculated 15.2 at the survey point, and if you don't get a survey, going back to 3A, we knew that it was going to be 15 million expected value to drill.
Okay, so yeah, so something's off there that it's 15.2, but you'd have to
Yeah, because
check.
so I took 85 times 0.56 to get me 47.6, and then negative 15 times 0.44 to get me negative 6.6. I
Okay.
add those together, I get 41.
Yeah, it could be rounding error. Hold on. Yeah, 41.
Yeah. And then from the 41, or underneath, I had the not productive, then you had success and not and unsuccessful. And that was 85 times 0.18 and negative 15 times 0.82 to give me a 3. And then I added 41 plus 3. Well, no, maybe
No,
that's
you
not.
wouldn't add them. And
No, yeah, you're right. No. So I wouldn't add them. So it would be
then you do 32% of 41.
30. Yeah, 32% of 41 would be 13.12, and 68% of 3 would be 2.04. Then I add those two together to give me a 15.2.
Yeah.
And then I compared 15.2 versus if you weren't surveying on 3A, which was 15, I just subtracted those two together and said the value of my imperfect information would be 0.2.
Yeah. Okay. That's rounding error.
Oh, how far out do we need to round? Two decimal places, 3, or
Uh, if you did an Excel, you wouldn't have this issue.
okay.
But just think about it conceptually for a second. What are you, if the survey says productive, are you going to drill or not drill?
If the service says productive, you would drill, yes.
And what if it says unproductive? What are you going to do?
If it says unproductive, technically you would still drill as well because you can still get 15, or the expected value is still 15 even if you had the survey or not.
Well, according to your calculation, it's 3, right? If we drill, the expected value is 3. if it's
y-
unproductive.
yes. Okay. Yeah.
Yeah. So no matter what the survey says, you're going to drill.
Right. Okay.
So this test has to be worthless. And any
Got it.
deviation from that's got to be like just rounding mistake, rounding error.
Got it. Okay.
That makes sense?
Yes. Yes, it does. I mean,
So,
just kind of talking it out, you got the survey, it's 15.2, and let's say the survey, I mean, even if you didn't get the survey, it's still 15. Yeah. Okay.
yeah. So,
So
if they,
should we be, eh, so
I mean,
like,
I would expect, I would try to avoid like a rounding error issue, like on a test, but,
yeah, because that was my follow-up. So I just use a 10 key on like a
yeah.
handheld 10 key
But,
and use a piece of paper. So for the midterm wise, do we just round up to the nearest whole number to make it easier, or
well, like midterm wise, I would expect you understand conceptually. If a test doesn't change anything you're going to do, it's worth nothing.
yeah.
Even if your calculation like gave you a different value. Right?
Hmm.
So I would try to keep it at
Yeah.
that level. Um, because this tree is, you've got a 32% chance of a 56% chance of 85 and a 68% chance of a 17% chance at 85.
Right.
So that's, you multiply all that together, that's 0.3. So this whole upper thing is no different than this. It's a 30% chance at 85,
Right.
70% chance at 15, because we always drill. So anyway, go to 4 decimals to be sure. Then you'll be
Okay.
less
I got
likely
you.
to get an error, but just conceptually, you should understand if we always do the same thing, then it's not worth anything.
Okay. Got it.
Okay. We can go back to Ashley, or we can. I assume Ashley's not driving. She's not in a Tesla, I don't think.
She's, I was gonna say she's in a Tesla.
No, neither. I think I just figured out what I was doing wrong as Frank was talking, and this is so silly, but I was trying to do this without using this. After you get, I shouldn't even say this, it'd be embarrassing. So after you get the 6832 on the productive, unproductive, and then you get, you divide, I'm doing it manually, so I'm dividing that by the 18 to get to the 56, right? So I'm backing into the wet dry for the productive and unproductive.
Yeah.
I'm plugging those back in to the other side to calculate against the 85, the 50, those other probabilities. For whatever reason, I was trying to calculate off of the new probabilities, but basically you create column L. I'm just saying you get column L, and then you have to go plug column L in your view back over in X, and now you're doing the calculation. Because as Frank was talking, I was like, I got the 25.5 and the 15 on A and B, but I was way off on C. But now you've got to apply those back to those original probabilities and calculate through. So I'm going to try that while other people are looking at
Yeah,
it.
you got to make this. I mean, this tree here
Mm-hmm.
is this and this.
Right. Column M though they aren't new. That was the probability we needed to do to get the wet dry probability. And then that just stays. And then you take those other units and plug those back into the original thing. I think I was trying to replace.
Oh,
Anyway, I don't know why, but obviously that was way wrong. So I figured it out now.
okay, good. We'll have to give Frank $1 when we see him. All right, this calculation, that's just statistics class. I know you guys didn't do trees, but maybe you talked about Bayes' theorem. I don't know. But there's no decisions right here. This is just statistics. This is just how do you update your beliefs given you've seen some data. What we're adding in this class now is decision making because like who cares about, I mean, this is fun, it's interesting, but the only reason we're doing this is because we need to make some decisions. And so this tree has no decisions in it. Over on the right, I've put the decisions in. In particular, there's a decision in between here. Like, given we've seen the test result, we get to decide, do we want to keep going? And then there's a decision right here. Right? So all this tree is doing is like taking this tree from stats class and then saying, hey, wait a minute, there's a decision in between here. And the fact that there's a decision in there means this information could be valuable. We're getting to take an action after we've learned something. And so that might be valuable. It's not in this case, but that's just this particular case, right? If we made this test more accurate, then if it says productive, we drill, unproductive, we don't drill. So yeah,
So,
but
so,
yeah, go ahead.
so now I see, okay, so I have the 15. Now I'm going back to what Frank said on the 15.2, but that's Frank on the 15.2 you were getting, was that right there where he's highlighted? You were getting 15.2 right there?
Yeah.
Yeah, because I was
Okay.
I was just rounding one decimal point. That's why.
I get it. I get it. So that's 15. And now we have to take the $5 into.
No.
No.
So
Okay.
now,
Okay.
so this is saying if you have the seismic survey, this is worth 15. Okay. If you don't do the seismic survey, you also have 15 because you're just going to go.
Mm-hmm. Mm-hmm.
So the value of the seismic survey
It's
is
okay.
the value
Yep.
with it minus the value without it.
Mm-hmm.
And that's 0 in this case.
Yep. Okay.
So you wouldn't pay anything. If you paid 5, you would be $5 million worse
Yep.
off.
Yep.
You're cooking now? So, right. So what I do in the video is I just say, look, these are all the same problem. Like Ursa, it's the exact same thing. Do we want to do a sneak preview? What do they say? Should we release the movie or not? And then what happens? This is the simplest information gathering problem we could have because the test can only report 2 things. We only have 2 alternatives, do it or not, and the outcome only has 2 things. In reality, the test result would be like some continuous thing, right? If you were doing a market survey, we want to determine is this new product going to be a success or not. It probably doesn't come back it's good or it's bad. There's going to be like a continuum of results that you'd have to deal with. That's just a computational issue. That's just saying, hey, there's more branches here. But conceptually, it's the same idea. And then I took our COVID example or our medical test example, 1 in 1,000, 99% accurate test, where we had to flip the tree and we had to calculate these probabilities, 9%. And I said, hey, let's say the decision is should we go see our grandma or not? So with perfect information, start there. See, perfect information is nice because you don't have to do this tree flip. It puts an upper limit, and the calculations are easier. You don't have to do any tree flip. So let's say we're thinking about taking a COVID test. If we don't do the test, we just have to decide, should we go see our grandma or not? Okay. Stuff in blue you can change. I just made this tree and I copied it down below and just changed it to all the different problems. And I'm saying, all right, if we go see her, there's a 1 in 1,000 chance we have COVID, let's say. And then we're going to expose her, right? And that'd be bad. You don't want to expose your grandma to COVID. So I just put some big negative number in there, minus 10,000. Okay, make it whatever you want. And then I said, but if I go see her and I don't have COVID, well, that'd be good. I get to see her, and let's say that's worth 100. Or I could choose just not to see her at all, and that's a 0. So if I multiply these probabilities times these, I get expected value of 89.9. I'm going to go see her if there's no COVID test. But if I could take one of these tests, okay, and I test, or sorry, not one of these tests. Let's do perfect information first. So see here, I have to act and then I learn. With perfect information, I learn and then I act. See, the order is different. Decision, uncertainty, uncertainty, decision. Here I'm getting to make these decisions with full knowledge as to whether I'm sick or not. Where here I'm having to make the decision being uncertain about if I'm sick. So if I knew I was sick and I go see her, that's a minus 10,000. If I know I'm not sick and I don't see her, that's a 0. I'm going to pick the max. I'm going to pick 0 and I'm not going to go see her. If I know I'm not sick and I go see her, that's 100. If I don't see her, that's a 0. I'm going to pick the max and I'm going to go see her. So notice I'm making a different decision given the information. If I know I'm sick, I don't see her. If I know I'm not sick, I do see her. That means this information is valuable. It's changing my decisions. Well, I move the uncertainty out front, so I got to multiply this probability times the value, this probability times that value. That gives me 99.9. So with perfect information, my decision's worth 99.9. Without that information, I've got to just go ahead and make my decision. I'm going to see her, that's 89.9. The difference there is 10. So the value of perfect information is 10.
Just a quick question. So the logic that you just said, I mean, I think that really helps in terms of like understanding the framework. Is there cases where the value of imperfect information is going to be something similar to like this drilling example where it is of no value to you? Is that more often than not? Because you have to make a decision, you don't know the outcome is I guess the mindset that you have to go into, right? So generally I guess the value of imperfect information, I guess my question is it always going to be 0? I think
No.
always is a very strong word, but more
No.
likely 0. Okay.
No, but what is true, so for sure it's worth less than perfect.
Okay.
That's for sure. And then the second thing is the value of information is very sensitive to its accuracy. Okay, and so small decreases in accuracy can result in very large decreases in value. So it's not true that, it's always 0, but I would say it's often the case that imperfect information is worth like a small fraction of perfect.
Okay, got it. So it'll always be less than VOPI and the value is tied to its accuracy. So I guess the less accurate, the lower the value, or is that
Correct.
just Okay.
No, that is a true statement. So
Okay.
less accurate information is never more valuable.
You said less accurate means like it could make massive ranges, right?
It's real sensitive to it, right?
Right.
Like, I mean, here, look. So here I've got imperfect. Again, that's exactly the same as Ursa and the drilling thing. But we got to flip the tree. If we test positive, there's a 99% chance or a 9% chance we're sick. This is the example we did in class. So if I test positive, I got to decide, should I go see her? Now there's a 9% chance of like giving her COVID, right? So you work out the numbers, you're like, that's a bad idea. So you're not going to go see her. If you test negative, it's not zero that you have it, but it's like small, it's like 1 in 10,000. So you go see her. Now you multiply the chance of testing positive times this, chance of testing negative times that, you get 98.8. So imperfect is worth 89.9. Or sorry, 8.9. But see, this test was 99% accurate. So a 99% accurate test is not worth 99% of perfect. 99% of perfect would have been 9.99. And this test is worth like 8.9. So we could, can I do something like, let me do something like this, slightly more complicated. I don't want to confuse you, but you seem interested. So let's say that I'm going to look at the sensitivity of the value of this test to the accuracy. So let's say accuracy could go from 0.5 to 1. This number could go from 0.5 to 1. I'm going to make this equal to this, just so I only have to change one number. Like if I make this 0.5, then this will change to 0.5. And what I'm going to plot, I'm going to use a data table. This is the value of imperfect information as a function of the accuracy. So if I do insert, no, sorry, data, what if analysis data table, my inputs are in a column. And I want to put those inputs right here. I want to try different accuracies and calculate the value of perfect information. Okay, and so you can see, right, as Frank is saying, this is the value of imperfect information as a function of the accuracy. The accuracy can't be less than 0.5. You couldn't have less than 50-50. So what you get is like the test, even like with a 60% accurate test, 80% accurate test, is worth nothing until you get up to a pretty high level of accuracy. Even at 90%, it's not worth anything. And then it really jumps up. So this is what I was saying. Right at perfect information would be right here. 1 and 10. If you decrease the accuracy a little bit, the value really drops. It drops really quickly. That's kind of generally true, but I can't say like, in every possible situation, this is what happens, but
Yeah, I gotcha.
pretty common. So, and I gotta turn this back to what we had. So anyway, this is, if that helps, it's again, just the exact same structure. It's, you get to learn something, then you get to make a decision, and then you see what actually happens. This is how you would value an option. on stock, right? If you buy an option on a stock, that's a value of information problem. You are paying to make a decision about whether to purchase it or not after you've seen the price. Right? If you buy an option on IBM, $80, you've got the right to buy it for $80 in the future. And you're going to do that if the day to exercise your option, the price of IBM is $230, then and you can buy it for 80, that's awesome. So it's the same structure. You get to learn the price of the stock, then you decide do you want to buy it, and then in that case you get the money. Okay, what other questions do people have?
On the Ursa Minor, can you scroll over to the left real quick? I want to see one of your charts that. On the chart with the blockbuster disaster versus the hit dud, did you manipulate and change that at some point, or is that what it's supposed to look like?
This one here?
Nope, to the far left, even further. Yes, sir.
This is so the only difference between this and what's on the PowerPoint is the PowerPoint hit and dud are here and blockbuster and disaster here. So it's just rotated
Gotcha.
90 degrees.
Yeah, no, thank you. I appreciate that because it scrolled earlier and I saw it and I was like, that isn't what I have. And so thank you for
It's
telling me.
flipped, yeah. And yeah, why? I don't know. Because when I start building the spreadsheet, I usually do it like this, and I don't know. My PowerPoint slide for Ursa's flipped from that. I don't know why.
Okay. Yeah, I appreciate that. Thank you.
But again, these numbers, the things in blue, you can change. Literally what I did is I built this example out. And I said, okay, well, I'm going to want to duplicate this. And so, instead of see grandma, it's, drill. And then it changes to drill everywhere here. Right? Or not drill. So you could use this in other settings. Maybe James can use it for one of his mining opportunities.
Okay. Professor Big, I don't know what I'm doing wrong. I just did a quick recalculation on 3C, and it took it out 4 decimal places, and my value prior to I guess the probability right after if you were to do the survey, I'm getting 11.4.
Now, can you share your screen, Frank?
It's on a piece of paper. I'm
Oh.
literally, yeah, I'm just going old school because
Yeah,
I was
11
gonna
point
scan
something's
it.
wrong. Something wrong there.
Okay.
I mean, that can't be rounding. So
Yeah,
what's your expected value if the seismic survey says productive?
So if it says productive, I got 41.25,
Okay, that should be
and then 32% of that is 13.2.
okay. What are you
And
getting
then
for unproductive? What's the
unproductive, I got 2.650,
yeah.
and then 68% of that is 1.00. So 13.2 minus 1.800 is 11.4.
Not minus, it's plus. It's a positive expected value.
Yeah, that's right. God dog it. Okay. Thank you.
Hey, Professor, I've got a question. It seems like with 3C on the homework, like the difficulty has gone up a notch, in terms of inverting tables and flipping tables and multiple tables. Thinking about trying to approach the midterm and studying for the midterm, the difficulty of that question versus what we might see on the midterm. Can you talk about that a little bit?
I'd say I'd expect you could do a problem like that, or that would be okay for the midterm. Some people, maybe not everybody could do it. The only, I mean, the structure, right, I think is pretty straightforward. Like you get a test result and then you got what's actually there. And it's just calculating these probabilities, which requires this flipping of this tree, which, you know, you don't even, if you don't even really have to know what you're doing, you just, hey, the probabilities, top one stays the same, the middle two flip, and then you can calculate all the other ones. This one's got to be the sum of those, and this has got to be this, that divided by that. So yeah, I'd say I think that's fair game for a test. I'm not saying it's on the midterm, but
Just one question. So if it is value of imperfect information, it's mechanically, you always have to flip it, right? You got to do step one and then do the step two. Is that a good approach, or is it going to be some nuances where, well, maybe you don't have to do that?
well, you always have to come up with this conditional probability. So, you know, what's my belief about the success of this thing given the data?
Mm-hmm.
And so if I didn't give you that number, you'd have to calculate it.
Okay, I gotcha.
So conditional probability is where we're grappling with the imperfect information is conditional probabilities.
Yeah, yeah, I would, you know, you make sure you know how to do this,
Mm-hmm.
like flip the tree, and then what we're adding is saying, well, given the data, we need to decide, do we want to do the project or not? So there's a decision in here, which we've put in right here.
Do you have any other advice as far as preparing for the midterm, aside from understanding this problem and conditional probability?
I just, yeah, I would, you know, assuming everybody knows, understands the homework we've done and the case exercises we've done. I don't go look like at the DQ book or anything to find problems for that. So I'd say, you know, stuff we've done in class, breakout exercises, homework exercises, making sure you understand those.
Okay, thank you.
Mm-hmm.
Our midterm is like open book, open notes.
Yeah.
Yeah, okay.
Yeah. And there's also you guys have a spreadsheet that does all the tree flips, and a simple tree flip spreadsheet here, which is the same thing that's in here.
Yeah.
But yeah, you can do them here too. All right, what else?
That's all I had.
James doesn't have a question?
Here, I've got another one. So in terms of looking at these incredible spreadsheets you've got here, basically value of perfect information. It could be sneak previews, it could be surveys, it could be COVID tests, it could, you know, basically
Market tests, yeah, any information gathering.
any perfect information is going to fit that tree template that you've built. Any imperfect information is going to fit that tree template that you've built.
Correct. Yeah. Now, I would say in this class. Now, and conceptually, I forget who do you work for, Jack? I forget.
I work for myself.
Okay. But what's your area, your industry?
I'm an architect and developer.
Architect, yeah. So like, I don't know enough about architecture, but like,
Well, real estate's a good example. I mean, looking at, you know, you look at comps today, what do they tell you about comps in a year?
yeah, that'd be a good one. Or, I was getting ready to say like, you know, construction, they've got to test the soil and, you know, is this soil strong enough to hold up this building? And so they take cores and they take them, you know, only at a few places, and then they've got to infer what's going on with this whole area where we're going to build. But, you know, in practice, there would be your data is not going to just say like good or bad, right? Your comps aren't going to just say good or bad. They're going to give you a whole range of outcomes. And all I'm saying is like conceptually, that's just like having more branches in this tree. And we could handle it. We're not going to do it here in the class, right? Because I think, right, as you pointed out, I think this is complex enough. So any of the problems we work in the class would be like no more complicated than this. But I don't want you to think like we couldn't handle something more complicated. It's just a computational thing. It's not conceptually, we know how to do it.
Okay, thanks.
Yeah. So understanding, you know, one of these
So,
examples. Anything you face on the test would not be any more than this.
and if you've been working these out by hand or in some other graphic program, is it time to like switch over to the spreadsheet and get good with these files?
I'm kind of mixed on that. I think sometimes on the exam it's almost faster to just do things, you know, by hand to draw it out, but you could make a calculation error. I mean, for me, like if I ask you to do something that requires a tree flip, it's fine with me if somebody comes in here, uses this spreadsheet, sets it up for the problem that we're talking about, because you know, you could change anything in blue and you get the answer. That would be totally fine with me because it's like, you know how to use the spreadsheet, you know how to interpret what it's given you. I think that's enough. So, you know, that might be useful on an exam. You know, and I could give you a whole new problem instead of drill baby drill, give you some new one. You know, if you knew how to use it well enough, you could change the values and then just copy paste the tree. You know, that would be fine with me. That's why I make it open book, open notes. So up to you.
Okay, thank you.
Yep.
Will you give extra points if we do it by hand?
Nah. So I made the spreadsheet because I wanted to show you that the structure is the same in all of them. So then okay, I'll just do it in the spreadsheet and then I can just copy paste this twice. And then I've got 3 examples for you. So that's the nice thing when it's digitally is you can just duplicate it.
Yeah.
I do have a question.
Yep.
Scroll down one more, a little bit to the whatever the second one is. It could be either the drill one, it doesn't matter. Whatever one is that we have to purchase something like a test.
Mm-hmm.
So it has the test, the 15. Is that the expected value? Is the 15?
That's the expected value with a free test.
Right. So I guess that was my question. Like, should that be like a negative, or I'm sorry, should that be like 14 instead for an expected value then?
I usually do it this way. I compute the value if the test was free, and then I subtract the value without the test. So that gives you the value of the test, and then I just compare that to the cost.
Okay. Is it wrong if we do it the other way? Because I've been doing it the
No.
other way, where like my expected value would be 14, the value of the not testing is 15. Therefore, I already know that it makes more sense not to test.
Yeah, doesn't matter if you take, this test costs 5, so you should have got 10, right?
Mhm.
So if you subtract 5 off of each of these, then this is just going to go down by 5. So you get 10. So that would be correct. Okay, what else?
I've been listening in. I haven't started question 3 yet. I finished 2 last night, but so that's why I've been kind of quiet. Just haven't really had much experience to fidget with this yet. But
Okay,
thanks for the review.
sure. You got some good thinking from your classmates went in here to put this together, so this spreadsheet ought to help.
Professor Bickle, quick question. I guess on Monday's session, are you going to go over the midterm, or are we not going to do that?
On Tuesday,
Oh, sorry. Yes, Tuesday. Yes, Tuesday.
if somebody asks me about it.
Okay. I will come with my questions then.
Yeah, work the midterm out. That'd be a good test. I think there's one of these problems on the midterm.
Yeah, there is. Yeah, it's like question. I was looking at, I think question
I think it's
3. Was it?
rapid scan. I
Yeah,
think
question 3 or question 4. Yeah.
Yeah, that's this device that checks for skin cancer. You guys familiar with Start Engine?
Mm-mm.
This is like crowdfunding. And so people list opportunities here, like here's this one here. This is My Radar. This is an app on the iPhone. And they're raising capital. They've raised 6.5 million in the past. You can buy equity in them now, $3.75 a share. Minimum investment's $500. You have to be an accredited investor. I think it's like 100,000 in income or something. It's not too much, but so you can buy equity, and it's private. And then if they go public, then or they get bought out, then maybe you would make some money. It's like venture funding. But there's a company on here. They're back on here. They were on here when I wrote that question. It seems like it's working right. Okay. This one. Vita imaging. So this is for skin cancer detection. And so instead of taking a biopsy, it uses basically laser light that they can put on a mole or something you might have. And within a second, it reports out cancer or not cancer. And it's got a certain sensitivity and specificity they talk about in here, and compare it to any alternatives. So obviously a lot faster than biopsy. It's got a 95% specificity. So anyway, I think that problem is like, should we invest in this company, and how good is their test? But if you're interested, they're raising money right now. They've about 1.2 million in the past. They've raised this round about 700,000.
Pretty cool.
Yeah, Start Engine's pretty cool. We're going to do a case from here. We're going to use Monte Carlo simulation to analyze one of these investments.
Kevin O'Leary?
What's that?
Is that the Shark Tank guy?
Yeah. He's an investor. You can buy equity in Start Engine. They've raised about like 83 million on here. This round they've raised about 6 million. But you can invest. So it's highly illiquid, right? These are private, so you can't, there's not an exchange that you could sell them. They do have a market where you can sell to other accredited investors after a year. So if I had some stock in Start Engine and you wanted some after a year, I could sell it to you. But
It's passive, it looks like.
yeah, they also have ownership of more significant real venture-backed companies like Epic Games. And this is like people who've worked for Epic and had shares in Epic. Again, and Epic is private. They have sold their shares to Start Engine, and then Start Engine resells them. So there's some pretty well-known private companies like Chime that you can buy ownership in before they've gone public.
I'm I'm surprised that some of these companies allow that for their employee, like if it's employee RSUs.
Yeah.
Surprised that they were allowed to do that.
Yeah, I don't understand exactly how it works, Frank. The companies are not authorizing this resale,
Mhm.
but somehow Start Engine has gotten ownership of the shares, and then they create a company that holds these RSUs, and what you're actually buying is a share in this company that Start Engine has created to hold these shares. I haven't done any of these. I've done several of the smaller companies. These, like the minimum investment is usually like 15 grand or 25 grand or something. It's quite a bit higher for these types of companies.
Have you had any success with some of these investments that you've had?
I only got into it like the last year. Um, so the ones I've bought, or they haven't had any kind of liquidity event yet.
Got it.
So
It's a long-term play.
yeah, but yeah, it's pretty cool. There's like a fair amount of alcohol on here. I bought one in a brewery in Hawaii because I like Hawaii. But there's a lot of alcohol and there's a lot of medical device or preclinical pharmaceutical companies on here. And then maybe things that people might have some brand awareness of, like my radar. I already had my radar. This is how I found it because I used my radar on my iPhone and they said, hey, we're raising equity on this thing called Start Engine. And I didn't know what that was. And that's how I got onto this. So anyway.
Interesting.
So the midterm came from here. So yeah, work that problem. We could talk about it on Tuesday.
Okay.
I don't want to drag you back into the class stuff, but did that spreadsheet, did you say you had shared that somewhere for us? We could steal from you?
Yeah, it's on there. Let me just go back. I put it so I made a module called asynchronous. 04 asynchronous, so like right after our last class. That's got the spreadsheet. I recorded a video going through the spreadsheet, talking about it. So if you want more info. And then I put up this little PDF, which this is from a COVID test I have at home. And it gives the sensitivity and specificity of the rapid antigen test. So I kind of talked through that and how you could put that into the spreadsheet.
Thank
All
you.
right.
Well, thank you very much.
All right, crew. We'll see ya.
Right. Thank you,
Thank
Professor.
you.
Okay.
Alrighty.
Okay, bye.
Much.